Oh, yes, welcome. I'm back again with physics questions from past papers. This one, typical question on momentum, impulse, and net force. Let's just go through the graph that is presented there. It actually stems from vertical projectile motion, although the question is not specifically from that topic. But if you look at the velocity versus time graph there, it clearly shows that the initial velocity of the ball there was 0, and the velocity time graph is a straight line with a positive, clearly showing that downwards was taken as positive. So which means even your gradient, if you do the velocity time graph, gradient would be g, because in vertical projectile motion, the object is under free fall, so only gravity is acting on the object. So you see, it hits the floor with a velocity of v1, and then it rebounds with the velocity of minus v2, which is smaller in magnitude to v1, and you can clearly see that the area under the graph is smaller there, clearly showing that t3 there is the time the velocity reached 0 there, that is when it reached maximum height. But the time it spent on the ground is actually T2 minus T1. I just enlarged it, although those would be just a few seconds on the ground, so that we can see the graph. So that is that, and then the options given for the net force magnitude of the force are these ones. So I want to emphasize how we calculate this when we have to determine the magnitude of the net force, and if it is a multiple choice question. So I'll start here. Net force is called rate of change of momentum. That's where we want to. But now we need to get the net force. We need to get the change in momentum acting on the object, given what we are given there. So it would be clearly, if I put it here, it would be, yeah, let me just write it and then plot. So it would be, the net force there would be, the momentum is minus, this is negative in the opposite. Let's take downwards is positive. Yeah, that's the first step. So it will be changing momentum would be minus mv2. Final velocity is negative, minus mv1 over t2 minus t1. Yes. So what is the problem is that most learners now would look at the options and say that, but they don't answer that way. Let me give you an example of a situation where the change in momentum is negative. For example, let's say V2 was minus 5. So, V2, not V2 was minus 5, let's say it was 2. If V2 was 2 meters per second, so that we take that as minus 2 times, let's say the mass of the ball was 2. So 2 times minus 2 will be minus 4, right? That is after collision, the momentum is minus 4 just after collision. And then just before collision, let's say the velocity was 3 meters per second positive times 2, that would be 6 minus 6 kilograms meters per second mass times velocity. So in other words, your change in momentum would be minus 10 kilograms meters per second. So if you were to calculate the net force, if the question was net force on the ball, it would be minus 10 over T2 minus T1. The negative sign will give you the direction that if you took downward as positive, it will show you that the net force is upwards. So you'd say 10 kilograms meters per, you calculate the net force, and you divide the 10 by the contact time, and your answer will be negative something, negative whatever. If the T2 minus T1 was 2 seconds, that would be negative 5 newtons upwards. But they want the magnitude. So in which case you would get rid of you just ignore the direction, the minus of the direction, and then divide the 10 by the contact time. But that is not what you are going to do in a multiple choice question. You have to do it mathematically, not just say, I ignore the direction and just take the magnitude. And you would not do that. That's the purpose, the reason why I raised this question, so that the learners who are preparing for exams can work on it. You mathematically, the only way to get the direction out there, because it would be a negative answer here, minus would be negative, is to multiply by -1. Let me do it, and then talk minus out into the bracket, minus, then into mv2 negative mv2 minus mv1, right? So over t2 minus t1. Now, if you work the numerator part to give you now mv2 plus mv1 over t2 minus t1. I hope that makes sense. So you see, mathematically, you multiply by -1 to get rid of that. That is the point that I wanted to make there. Then another point that is important here before I close is that if you are dealing with two balls, if you calculate the change in momentum of one, change in momentum is also impulse. If you calculate the impulse of one ball, if they say it's -4 kilograms meters per second or -4 Newton seconds, the impulse on the other ball will be will have the same magnitude but different sign. So I hope that helps. And so the best answer here would be MV2 plus MV1, although they wrote it as MV1 plus MV2. You know, A plus B is the same as B plus A. That's the only thing that some learners will say there's no the correct answer there. So thank you. I'll be back again with more videos. Yeah, I hope you enjoyed this one. It's a short one. Thank you so much. Bye.